Hi everybody and welcome back. This is the final lesson in the similarity unit. So we've covered so far dilating shapes, looking for scale factor, looking for center of dilation, how that works on a coordinate plane as well as on construction. Then we moved into proving triangles were similar and triangle proportionality theorem, angle bisector theorem, and then getting back onto that coordinate plane again, making sure we could answer some different challenge questions about that. We had some Khan Academy work built in. And then in the last lesson, we also looked at dividing a line segment by a given ratio. So that idea of proportionality, and then when it's on a coordinate plane, using similar triangles to do that. Today is all about geometric mean. So what is it and how do we use it to solve different problems? Okay, so you've heard of algebraic mean before, which is the average of two numbers. You add them together, you divide by 2. The geometric mean is when you multiply two numbers and then take the square root of their product. So it's a different type of average. So geometric mean, you're going to multiply two numbers and take the square root, and we're going to see how that applies to triangles now in a second. All right, so on a triangle, when you have an altitude, so an altitude is the perpendicular height from one side of a triangle to an opposite corner. So there's 3 different altitudes on a triangle. So in our case, the x in red is an altitude of this triangle. So it's going from one side perpendicular to it to the opposite corner. And there actually are 3 altitudes. This would be an altitude as well. And so would this one, depending on which way the triangle is turned. So they are both perpendicular heights of the triangle, depending on which side is at the base. So x is that perpendicular height. So what we find is with geometric mean, the altitude of a triangle is equal to the geometric mean of the hypotenuse. So the way it's divided. So we draw in this altitude and it cuts the hypotenuse. So the total hypotenuse here is 10. But when we draw that altitude, we get side lengths of 2 and 8. And what we realize is that if you do geometric mean for this, so that is 2 times 8. And then remember, geometric mean, you do square root of that, you will get x. So in our case, 2 times 8 is 16. Square root of 16 is 4, so x is 4. So pretty straightforward. You're going to mostly be applying this to hypotenuses and altitudes, and you're going to use that to solve for missing values. You may also be asked to solve for the other 2 sides here, because when you look at it now, you have 3 different right angle triangles. So Pythagoras' theorem will be fair game in this one as well. Okay, let's take a shot at a question. So here's your triangle, and you're being asked to solve for x, y, and z. So looking at this, we are given 3 and 27, so the total hypotenuse length is 30. Just worth kind of keeping an eye on that. We want to solve for x first. So just kind of throwing in some other right angles in here that maybe you didn't see. So we have that one. We've got right angle triangle up here, and then we've got the full outline as a right angle triangle. So there's 3 right angle triangles, all of whom are similar to one another. All right, so geometric mean, 3 times 27, and we want the square root of that, and that's going to be equal to x. So x is going to be 3 times 27 is 81. Square root of 81 is 9. So x is 9. Now, if we look at right angle triangle in here, we know 2 of the sides, 3 and 9, and we want the hypotenuse. So it's the hypotenuse because it is opposite the right angle for that little triangle. So now we're into Pythagoras' theorem. 3 squared plus 9 squared equals y squared. So that would be 9 plus 81 equals y squared. 90 is equal to y squared. We're going to square root both sides because squared and square roots cancel each other out. So the square root of 90 is going to be our hypotenuse length. So square root of 90 is 9.486. So if we're rounding to the nearest say 100th, that'd be 9.49. Okay, and then moving down to the bottom, z, again, another right triangle. You know 9, you know 27. So 9 squared plus 27 squared is going to be equal to z squared. And it's hypotenuse because it's opposite the right angle for this particular triangle. All right, so 9 squared, 81. And 27 squared is 729. I apologize. 729 equals z squared. So that's going to be the square root of 810. Square root of 810 is 28.46. So 28.46 is equal to z. Done. So it's going to be very repetitive. Like, keep an eye out for that geometric mean. The hardest part will be when this gets mixed in with other questions. You're like, okay, here's a question. All it says is solve for x, y, z. It won't say use geometric mean to solve for x, y, and z. So just kind of practice that idea of recognizing. Maybe throw it in next to some other questions from like Pythagoras' theorem or some similarity questions, proving triangles congruent, and just make sure you can recognize them. You also have a practice test available at the end of this lesson, so make sure that you are looking at that and trying to pick out where are the geometric mean questions. All right, second one on your own. Here's your triangle, solve for x. So x in this case is over here this time, so just a different way of looking at this question. Pause the video, take a shot. Okay, so we're still going to set it up as if we were solving for the geometric mean. So what it means is that 10 is equal to the square root of 5 times x. All right, so this is our setup. Square root of 5x, not easy to get x out. So remember, x is inside of this square root. You can't just divide by 5 or divide by root 5 on both sides. You got to get that square root out of there so you can start accessing that x. So what we're going to do is we're going to square the whole thing. Because remember, squares and square roots cancel. If we do that on the right side, we must also do it on the left to keep the equation balanced. So 100 is equal to 5x. Now see what happened there? So we got rid of the square root by squaring both sides, so 100, and then when you get rid of the square root, you're left with the 5x. Now we just divide by 5 on both sides, and we get 20 is x. So once more, if you were asked to solve for the missing sides, like you could solve for the hypotenuse over here, and same with the one down here now that you have the information that you know. So just keep an eye out for that. What you'll notice, 5 is half of 10, so shortest side is half of the middle side. On this triangle down here, shortest side is 10, medium side is 20, also half it. So it is a proportional triangle, side angle side. These are similar triangles. So if we were to solve for D, we would know that C is going to be half of it, or if we solve for C, we know D would be double that. So it'll be a way of figuring that out using a different method. All right, that's it for today. Really short one. So what does geometric mean? It's when you multiply two numbers and then get the square root of their product. How do we use it? When you have right angle triangles and you have an altitude for that triangle. So it's the right angle has a line segment coming out that is perpendicular to the hypotenuse. So it creates a perpendicular height for that triangle from the hypotenuse. That altitude is equal to the geometric mean of how it divides up the hypotenuse. So it's a little bit of a mouthful in terms of explaining that, but I think you guys got the idea. So to go with this, there's a geometric mean worksheet. Take a shot at it, answer keys provided, so make sure that you check your work, see how you're doing, and then start taking a look at the practice test and making sure that you are good to go for our test on Friday. Talk to you soon.